Good morning, all of you. Hope you all are good. And I can see very few are joined yet. Come on, join first so that we can start our class. And this is the fourth session of the chapter Sound. Fourth session of the chapter Sound. We'll continue the chapter. Come on, join first. Okay. I can see very few are joined yet. Around 14, 15 are joined yet. Where the others? Okay, all of you get ready with your physics notebook and we'll do some numericals. After that, we'll discuss the rest of the part. Okay, and as you know that today 3:30 is your CP2 and the syllabus is sound. Whatever we have discussed in this live videos, okay, whatever we have discussed in this live videos are important. Okay, 3:30 I'm giving you the time so that you can, if you want to prepare something more, you can watch the videos and see that and whatever is required. Okay, so today 3:30, you know that, you know the timing. 3:30 chapter is sound. Now all of you write question in your copy. All of you write um, a radar, radar. Okay, a radar, a radar sends, sends sends a signal to an aeroplane. A radar sends a signal to an aeroplane at a distance of 300 kilometer, at a distance of 300 kilometer, comma, comma, with a speed of 3 into 10 to the power 7 meter per second. 3 into 10 to the power 7 meter per second. After how much time? After how much time time is the signal, after how much time is the signal received back? After how much time the signal received back? Okay, so I think you have understood the question. Radar, okay, radar is there. Radar sends sound, it's sending sound. The sound is going and it is getting reflected by the aeroplane and it is coming to you, okay, to the radar. Okay, so this is the radar. From the radar, the sound is going and it is getting reflected from the aeroplane and again it is coming to the radar. So they are saying that after what time the radar will get the reflected sound back. Can you solve this? First you try. After that, this is the sum of simple reflection of sound. Simply reflection of sound we have discussed in our last class. Just use that formula, those things will be done. Just use that formula, that's enough. Time is 0.0 second. Okay, what formula you used? La, time is Sneha got 0.02 second. Priyansh Kumar has got 0.0000001 second. Different answers. Which formula you have used? Let me solve it. Which is correct? I do not know. Karmaka has got Ratul Karmaka has got 0.002 second. I don't know. Let me solve it. Let me solve it. 2D equal to S into T. I hope you have used that formula. 2D equal to S into T. Okay. 2D equal to S into T. Now, 2 into distance. What is the distance? Distance. What distance I said? 300 kilometer. No? 300 kilometer. Equal to speed 3 into 10 to the power 7 into time. Right? What is the speed given? 3 into 10 to the power 7. 300 kilometer. Okay. But 300 kilometer and what is the speed? 3 into 10 to the power 7 meter per second. Right? So 300 kilometer has to be converted into meter. Understood? 300 kilometer has to be converted into meter. So it will be 2 into 3 lakh. So 300 kilometer converted into meter, it will be 3 lakh equal to speed. What is the speed? We do not know. Oh, speed we know. 3 into 10 to the power 7 into time. So time equal to 2 into 3 lakh 3 into 10 to the power 7. So it will be by 3 10 to the power 1 2 3 4 5 5 means 2 by 10 to the power 2 means 100. So 2 by 100, 2 by 100 means 0.02. 0.02 is the answer. 0.02, 0.02 second. This is the time. Those who have got 0.02 second, they are correct. 0.02 second. Let me see who got 0.02 second. Sneha got 0.02 second. Then who is this Shampa Pal? I'm not able to recognize. I think he or she is using his parents' account. Jasraj got 0.002 second. That is wrong. Sahil Sharma saying late. Okay, Sahil Sharma. Nitik Deb got 0.02. Oh, Maitri Chanda. Okay, Maitri, you have solved this. She has got Maitri has got 0.02 second. That's correct. 0.02 second. Yes. So 0.02 second is the answer. Okay. Student, one thing, are you able to listen me, or can you see me clearly? Is it clear? Because it's raining outside. It's raining outside. The network is not so strong. Can you see me clearly? Is it clear? Okay. Okay, it's clear. Okay, because it's raining outside. That's why. So you understood this question? Radar. Radar means radar is something which sends the signal and receive the signal. Means the function of radar is to measurement the distance. To measurement the distance. Okay. Now next. Now, uh, next question. A person is standing. A person is standing at a distance of. A person is standing at a distance of 12 meter. A person is standing at a distance of 12 meter, 12 meter from a vertical cliff. 12 meter from a vertical cliff. CLIFF, cliff. And fired a gun. And fired a gun. Do you think, question, write it down. Do you think the person will get the echo? Do you think that person will get the echo? Question mark. Do you think the person will get the echo? Question mark. Then write why? Question mark. Okay? Why? Question mark. So if you say yes, you will get the echo. Why you will get the echo? If you say no, he will not get the echo, then why he will not get the echo? Both the reasons you have to write. So can you answer me? You will get the echo. Just shortcut way. Don't write in lengthy. Just write the keywords so that I can understand and what you are what you want to write. I will understand it. Just write the keyword. Will you be able to hear the echo? If yes, why? If no, why? Just write it. Okay. Uh, I got the first answer, I think. Acha, Mritik Dev. What Mritik? No, he will not, as the minimum distance required is 17 meter to get the echo. Acha, Maitri, what she is writing? No, the person will not get the echo because to hear the echo, person must be at a distance of 17 meter. Okay. No, sir, because the distance is, yes, all these three students are correct. Nitik Dev, Nitik Dev, Maitri Chanda, Priyansh Kumar. All these three students are getting full marks because the minimum distance to get the echo is 17 meter. Jasraj is also writing. Very good. So all the four students are getting full marks because the minimum distance to get an echo is 14 meter. So the person is standing at a distance of 12 meter or 13 meter, whatever I have given. It's not 70 meter. So minimum distance is 17 meter minimum. Okay, fine. Okay, Latul Karmakar has also written, no, the person will not get the eco. Okay, okay. Sneha Chatterjee also, no, because this is fine, fine. Good, good. So Mritik Deb, Maitri, Priyansh Kumar, Jasraj, Sneha, Ratul. Okay. Hmm. Okay. Now, now, right. One question. The amplitude of the wave, write it. The amplitude of the amplitude of three waves. The amplitude of three waves are 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 2 centimeter, 3 centimeter, and 4 centimeter respectively. The amplitude of three waves are 2 centimeter, 3 centimeter, and 4 centimeter respectively. Okay. Then the amplitude of three waves are 2 centimeter, 3 centimeter, and 4 centimeter respectively. Find the ratio of their loudness. Find the ratio of their loudness. Okay. Pratham Rai is coming now. Pratham Rai, good morning, sir. Good morning, Pratham. Late you are. Now he will say no network. Network problem, he will say. Okay. Okay. Write it down. Pratham, you also write. I recharge my phone. Are Pratham has recharged his phone. Okay, okay. Okay. So what I was saying that what I was saying that 2 centimeter, 3 centimeter, and 4 centimeter are the amplitude. Yes. So what is the ratio of their loudness? Ratio of the loudness. To find the ratio of the loudness, uh, what do you have to do? Just find their squares and take out the ratio. Okay. Just find their squares. Means 2 centimeter, 3 centimeter, and 4 centimeter. So just find the square of that. Means 2 square is to 3 square is to 4 square. Okay, this is the ratio of loudness. So L1 is to L2 is to L3 equal to, this is the way. See, first of all, you answer me. Is it visible clearly? Is it visible clearly? See here, L1, L2, L3, the ratio of loudness equal to amplitude square, amplitude square, amplitude square. 2 square, 3 square, 4 square. Okay. 2 square, 3 square, 4 square. Just find the ratio of that, you will get it. Okay. 4 is to 9 is to 16. 4 is to 9 is to 16. This is the answer. This is the way I have solved. Okay, so loudness is the square of amplitude. So if I ask you what is the relation between loudness and amplitude, then you will answer me loudness is proportional to, directly proportional to square of amplitude. Understood? Loudness is directly proportional to the square of amplitude. You must remember, don't forget. I hope all of you have solved. I hope Pratham is also writing all this. Okay, so we got this new relation. Loudness is directly proportional to the square of amplitude. Okay. Now, now the last part of this chapter, okay, which we are going to discuss now, the last part of this chapter, and this last part is really complicated, really very complicated. It's not a small part, it's a large part. Okay, it's a large part, and it's really complicated. So concentrate what I'm saying. Wherever you will have got doubt, just write in the comment that this is the portion you have got doubt. Be very concentrated. Just concentrate. First of all, what we are doing, we are taking a simple wire. Okay, we'll take a simple wire. So this is the wire I'm taking. Okay, so this is the wire I have taken. Fine. This side and this side means this end and this end are on the rigid surface. Okay, it's a straight wire, and both the ends are tight with the rigid surface. Try to understand, all of you. This idea is little bit complicated. Okay, idea is little bit complicated, the last portion of this chapter. So what I said this is a wire. Okay, this is a wire. This end and this end are tightly with the rigid surface. Okay, something like this I'm showing you. Say this is the rigid surface, this is another rigid surface, and this is the wire or the string. Okay, this is the string or the wire you have taken. Understood? And the length of this wire is L, small l. Length of this wire is small l. Correct? Length of this wire is small l. Now try to understand, all of you, very clearly. See what I'm doing now. What is the length of the string? L. What is the length of the string? L. I'll divide L by 2. Okay, I'll divide L by 2. L by 2 means where? Here. I will touch it and I'll take it here and leave it. You understood what I said? This is the length L divided by 2. L by 2. L by 2. Where is L by 2? Somewhere here. Take it and pull it. Pull it and leave it. What will you observe? It will keep vibrating. It will keep vibrating. Understood? It will vibrate like this. See, it will vibrate like this. It will go up, down, up, down, up, down, up, down in this way. Okay, it will go up, down in this way. Means it will vibrate. Very simple. Okay. Now, this is called principal note. Principal note. Understood? So whenever a string is there, you are you have to touch at the middle, means where is L by 2, L by 2, and pluck it or pull it and leave. You'll see it's vibrating. It's vibrating. Okay. This is called principal note. Okay. Any doubt? Principal note. So length is L. Now, can you tell me what is the wavelength of this? What is the wavelength of this vibration? Think. All of you just think. What is the wavelength of this vibration? Let's see who can answer. What is the wavelength of this vibration? Nobody? Nobody can answer. Okay. Okay, let me help you. Wavelength means Machi Chanda is saying L. Karan Mitra is also saying L. Okay, Machi Chanda and Karan Mitra said L. Okay, no problem. Let me help you. Listen, what is wavelength? Wavelength means the length of complete wave. Length of complete wave. Understood? I repeat, wavelength is the length of complete wave. Are you getting complete wave here? See, from here to this is the half wave and this is the full wave. Okay, from here to here, this is the full wave. Means if I draw full wave, this is called full wave. See, this is called full wave. From here to there, this is called full wave. Okay, full wave. From here to there, this is called full wave. But here it is half wave. See, half, only half. So half wave is not there. Half wave is not there. So this is half. Means this much is L. So this is another L. So wavelength is 2L. Understood? From here, this is L. This is another L. So wavelength is 2L. Understood? Wavelength is 2L. So wavelength equal to 2L. Understood? We know an equation V equal to nu lambda. V equal to nu lambda. So V equal to nu lambda. I will tell you what I'm doing. It's very important. V equal to nu lambda. So see what I've done. I hope you understood how the wavelength is 2L. Wavelength means the length of complete wave. Length of complete wave. This is called complete wave from here to here. This is called complete wave from here to there. So this much is L, this much is L. So wavelength is 2L. So here wavelength is 2L. See, wavelength of P. P means principal. I told you this is principal note. This is called principal note. So wavelength of principal note is 2L. And we know that V equal to nu lambda. V equal to nu lambda, we know this relation. Nu, I am writing nu P. That is the frequency of principal note. Frequency of principal note, nu P, equal to wavelength of principal note. Put the value of this lambda P. Lambda P is 2L. Put this 2L. So nu p equal to V by 12. So frequency is V by 12. So see, from here, we discussed what is called principal note, what is the wavelength of principal note, what is the frequency of wavelength note, principal note. I told you, the idea is really complicated. Okay, the idea is really complicated, but it's easy if you understand. So what I have done first, I took a string whose length is L and divide that length by 2, that is L by 2. Okay, and take it and pluck it and live. You will see the vibration. Okay, see the vibration, but you will see half vibration, that is L. So what is the complete vibration? 2L. Wavelength is 2L. So in this way I've written wavelength 2L, and velocity equal to V equal to nu lambda, nu p lambda p. So I have taken out principal notes frequency, that is V by 12. All of you write it. All of you write it down and write here principal note. First you write here principal note. After that you write all this. Write here principal note, then you write all this. Very important. Very, very important. Write it. And when you are done, just say done. This drawing is also required, okay? Principal note, this drawing, right here, principal note. Drawing, length L, lambda, frequency, everything you find. And when you are done, just say done. Done? Okay. 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 So we understood what is called principal note, what is the wavelength of principal note, and what is the frequency of wavelength note. Correct? Now consider the same wire. Same wire. Okay. In case of principal note, from where you plugged, all of you listen me very carefully. Listen me very carefully. The things are getting complicated now. So first of all, I said this is the string, this is the string, and L is the length, and divide L by 2 means here, and pluck it, leave it. Okay. Now divide by 3. Okay. First of all, you have divided by, yes, 2. Now you divide by 3. Okay. If you divide by 3, first, second, third, if you divide by 3 and if you pluck it, what you'll get? You'll get like this. So where I'm dividing now? First I have divided L by 2. Now I'll divide L by 3. Okay, L by 3 I'll get. So 1, 2, 3. I will show you. This one. If you plug this way, you will get this. Okay, you'll get this figure. Understood? You'll get this figure. This is the vibration you will get. And this is called first subsidiary. First one was principal note. And this is called first subsidiary. Okay, first subsidiary. This one. So can you tell me what is the wavelength here? What is the wavelength here? Can you tell me? What is the wavelength here? This is L and this is also L. Okay, length of the string is L. L, L. So what is the wavelength here? Can you tell me? Let's see. Wavelength, Ratul is saying L. Other students? Karan is also saying L. Nityadev L. Sure. Sure, is it L? Other students? Maitri, where are you? Maitri, Maitri is L. Okay. Other students? Rohit is also saying L. Rohit L. Then Maitri is also, all are saying L. Sneha is also saying L. Sure. Okay. Karan is saying sure. Okay. Tavabrata is saying L by 2. Okay. The correct answer is L. Because, see, this total is L. See, this one, this. Okay, from here to here, this is the complete vibration. So this is L. Okay, L. Fine. Understood? So what is the, so here lambda or lambda 1 you write, lambda 1 like this, lambda 1. Why I'm writing lambda 1? Because lambda 1 is the wavelength of first subsidiary. Wavelength of first subsidiary. That's why this is first subsidiary. Lambda 1 equal to L. What is now next equation is V equal to nu lambda. By that equation find the frequency like the previous one. V equal to nu lambda. What is nu? Nu 1 lambda 1. V equal to nu 1. What is nu 1? Nu 1 is, we do not know, lambda 1 is L. So nu 1 equal to V by L. This one. This is the way. This is first subsidiary. You must write first subsidiary before this and draw it and find the lambda 1 and V equal to nu lambda, V equal to nu lambda this way. Find it. So frequency equal to, frequency of first subsidiary equal to V by L. Solve it. This is first subsidiary. Okay. So principal note we have done. Then first subsidiary we have done. Now we'll go for second subsidiary. So what is second subsidiary? See. This is second subsidiary. Okay, the length is L. This total length is L. Total length is L. Now, can you tell me what is the wavelength now? Wavelength. Wavelength is wavelength 2. I am writing lambda 2. Why lambda 2? Wavelength of second subsidiary. Okay. Lambda 2 means wavelength of second subsidiary. So what is lambda 2? Can you tell me what is the wavelength here? This is the figure. See. This is the figure. This is the figure. What is lambda 3? Sorry, what is, yeah, what is lambda 2 means what is lambda? What is the wavelength? What is the wavelength? You also draw it. You also draw it and try. I told you before, the idea is really complicated. Idea is really complicated. Okay, I got the first answer. Ratul is saying 3L by 2. Okay, 3L by 2. Then Mach is saying 2L by 3. Ratul said 3L by 2. Mach said 2L by 3. Okay. Right Prashad 3L by 2. Uh, uh, Sneha Chatterjee is writing L plus L by 2. Current 3L by 2. Any other answer? Okay, let me help you now. You will understand who is correct. Who is correct? You will understand it now. Let's see. Like the answers which I have got, Ratul said 3L by 2, Maitri said 2L by 3, Rohit Prasad 3L by 2, Sneha L plus L by 2 means 3L by 2. Okay, Sneha is also 3L by 2. Karan is also 3L by 2. Let's see which is correct. Let me help you. Okay, this total is L. This total is L. So how much is this? See, three parts are there. Three parts are there. Means this part is L by 3. This is also L by 3. And this is also L by 3. Understood why? Because this complete one is L. So this is L by 3. L by 3. L by 3. So this is L by 3, L by 3, L by 3. Now what is the wavelength? Wavelength is from here to there. So L by 3 plus L by 3. That is 2L by 3. L by 3 plus L by 3. That is 2L by 3. Okay, so wavelength is 2L by 3. So who has written 2L by 3? That is correct. Maitri has written 2L by 3. Maitri is correct. So wavelength equal to 2L by 3. So lambda 2. Lambda 2 is the wavelength of second subsidiary. Second subsidiary, that is 12 by 3. Now Pratham is writing 12 by 3. Okay, so what is the wavelength? Wavelength is 12 by 3. Why? Because L by 3, L by 3, L by 3. Okay, now from here to there. So L by 3, L by 3. That is 2L by 3. This is the way. Now, same way, V equal to nu lambda. What is V? We do not know. V nu lambda. Nu lambda. V equal to nu lambda. So, nu 2 equal to 3B by 2L. So, this one. Say, V equal to nu lambda, nu 2. Why nu 2? This is the frequency of second subsidiary. Wavelength of second subsidiary. So V equal to nu lambda. So nu equal to this one. Try to understand this. 3B by 2L. So frequency of second subsidiary is 3B by 2L. Okay. Try to understand. I told you this is really complicated. The last part of the chapter sound is really complicated. Try to understand. So nu 2 is equal to 3B by 2L. This is the answer. Okay, nu 2. Ratul is saying, sir, but next step will not calculate. Next step is not required to calculate because what is wavelength? I told you to find the wavelength. Okay, try to understand me. I told you to find the wavelength. Wavelength is what? First up, then down. That much. Say you got 5 kg potato from market. 2 kg tomato and 1 kg brinjal. Okay. So what I said, 5 kg potato, 3 kg tomato, 1 kg brinjal. Now I'm asking you, how much potato you bought? You will say 5 kg potato. Tomato and brinjal you will not add because that is not required. Which is required? Potato is required. So here what is required? Wavelength is required. Wavelength means up, then down. Finished. Okay. Rest part will not calculate. I hope you understood. So what is the wavelength? Wavelength is starting from here to there. Yes. From here it is starting to there. This is wavelength. So L by 3, L by 3, L by 3. So this is L by 3 plus L by 3. That is 2L by 3. This is the thing. Okay. Now, so we saw principal note. First subsidiary, second subsidiary, everything we saw. Now we'll take out the ratio of wavelength and ratio of frequency of all these waves. Okay, let us find first the ratio of wavelength. Ratio of wavelength. Ratio of wavelength is ratio of wavelength. What is the wavelength of principal? V by 2L. V by 2L is 2. What is the wavelength of first subsidiary? V by L. Try to understand, all of you. What is the wavelength of second subsidiary? 3V by 2L. 3V by 2L. This is the way. See. Wavelength of principal, first subsidiary, second subsidiary. I'm just putting the values. Okay, putting the values. So you can cancel V, 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 L, L, L. We can cancel V, 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 L, L, L. I'm cancelling. So I'm getting 1:2:3. Yes. See, this is the ratio of the wavelength. So VL, VL cancelled. Now, what is it down? 2. 2. Multiply all these numbers by 2. This one will multiply by 2. This is also multiply by 2. This one is also multiply by 2. You will get 1:2:3. This is the answer you will get. Try to understand. I hope it's clear to you. 1:2:3. One is to 2:3. I said this is the wavelength of principal node, wavelength of first subsidiary, wavelength of second subsidiary. V by L, V by L, V by L are cancelled. What is that down? 2, 2. So multiply all this number by 2. Okay, multiply all this number by 2. So if you multiply this by 2, you will say get 1. If you multiply this by 2, you will get 2. If you multiply this by 2, you will get 3. So 1:2:3 is the answer. That is the ratio of wavelength. Now what is the ratio of frequency? Nu P is to nu 1 is to nu 2. Okay. What is the ratio of frequency? What is the ratio of frequency? We'll get now. What is nu P? Frequency of principal node. V by 12. V by 12. One more thing. One thing. Here, first we took out the ratio of the frequency. Sorry, that is not the ratio of wavelength. Ratio of the frequency. this is the, say, this is the ratio of the frequency, not wavelength, sorry. This is the ratio of, not of wavelength, I made it mistake. This is the ratio of frequency, say, ratio of frequency. Now we'll take out the ratio of wavelength. This is the ratio of frequency. Okay, this is not the wavelength, ratio of frequency. Now, ratio of wavelength. What is the wavelength of principal node? 12. What is the wavelength of first subsidiary? L. What is the wavelength of second subsidiary? Second subsidiary wavelength is 12 by 3. This one. Say, actually this was the ratio of frequency. Ratio of frequency 1:2:3. And what is the ratio of wavelength? Lambda p is to lambda 1 is to lambda 2. Lambda p is 12, lambda 1 is L, and lambda 2 is 12 by 3. So cut all L, L, L. Let us cut this L, L, L. Okay? See, L, L, L cancelled. Now what is it down? 3 is it down? 3. So by 3 you multiply all this. Since 3 is it down, so multiply by 3. What we are getting? 6:3:2. This is the answer. 6:3:2. This is very important. This is very important. What we have discussed now. So 6:3:2. This is the ratio of wavelength, and 1:2:3. This is the ratio of frequency. Very, very important. Okay. Ratio of wavelength, ratio of frequency. Got it? So you must complete it nicely. Okay? You must complete it nicely. This is very, very important. So, we discussed principal node, first subsidiary, second subsidiary, and we took out the ratio of the wavelength and ratio of frequency. This is very, very important. In exam, you might get these three, or you can get principal node and first subsidiary, or principal node and second subsidiary. In this way, you'll get in the exam. Got it? So this is the style of taking out their ratio of wavelength and ratio of frequency. Okay, so with this portion you can say that your chapter light is over. And don't forget about the test. When is the test? Yes, 3:30. Today 3:30 o'clock you will have a test of 10 marks. Understood? So 3:30 is the timing. Chapter is sound, and sound is over. Got it? So now, all of you, those who are present now, just write your name once, then you can leave the class. Okay? Those who are present now, just write your name, leave the class. Priyash Kumar is asking, sir, where CP1 marks and CP2 marks? I'll say it together. Don't worry. CP1 and CP2. One class I'll take. In that CP1 and CP2, both the marks will be told together. Don't worry. Okay.